Welcome to all in this video lecture series of computer networks. My name is Deepak Aneja, Assistant Professor, ABES Engineering College. In this video, I am going to discuss the topic subnetting. Now, subnetting means a bigger network is divided into the smaller network. Now, the question arises, why to divide the network? Because it is easy to maintain the smaller network for the network administrator and easy to provide security. For this purpose, we create the subnet for a large network. For example, if we take a class A address, in the class A address, the first octet represents the network ID system, and remaining three octet that is used for host ID. Now, it means in a single network, there is 2 raised to the power 24 host. That is a very uh, large number of, huge number of hosts are connected. So, how to do? Now the question is how to do subnetting. For the subnetting, we use the most significant bits from host ID. Suppose if we have to divide this network into 8 subnet. For this 8 subnet, this is divided into 2 raised to the power n. For this, to create the 8 subnet, we require 3 bits. 3 bits means 2 raised to the power 3, total 8 number of subnets we will create. So for this, we use 3 most significant bits from host ID. Remaining 21 bits are used for the host. We will understand this term more clearly with the example. For example, this is an ABES network. For the outer world, its IP address is 192.168.1.0. This is class C IP address. Suppose we have to divide this huge network into smaller 4 subnet. This is for exam department. This is for registrar office. This is for CCPD and this is for labs. Now, how to divide this network to these four subnet? Now, we will understand this 192.168.1.0. This is the class C address. For this class C, first 24 bits are used for network ID, or remaining 8 bit is used for host ID. For subnetting, for subnetting, we use the most significant bit from host ID. For host ID, there is 2 raised to the power 8 hosts are connected this network. Now we have to divide this network into 4 subnets. 4 subnet means 2 raised to the power 2 bits. So we use 2 bits to represent these 4 subnets. Now subnet 1, suppose we represent as S1, S2, S3, S4. Now this is S1, S2, S3. Now it will start from 192.168.1. There is 8 bit 1, 2, 3, 4, 5, 6, 7, 8. In this, these 2 bits are used for subnetting. Initially, this will be 0, 0. And for S2, so 1, 2, 3, 4, 5, 6, 7, 8. This is 0, 1. From 0, one. Now, what is the first address? The for first address for the host. Now for host, we use remaining 6 bits. So this is all 6 bits of 0. This is the first address for the, this is the first address for the subnet S1. And for the last address 0, 0, remaining 6 bits are 1. So all are 1. When we convert this into the decimal number, this represents 0, 0, 2, all ones are, this is 63. Now for the S2, the starting, all are zeros. This is the last address. For the subnet S1. Now the first address for the subnet S2, this is 64. 64 to the maximum 0, 1, 1, 1, 1, 1, 1, 1. 6 are. This will be represented at 127. For the subnet S3, starting is All remaining 6 bits are 0. Let's start with 128 or the maximum 10. Remaining 6 bits are 1. This is 190. For this, all 6 bits are 0. This is 192, 2, 1, 1. Remaining 6 bits are 1. So this is 255. So the 4 S1, the addresses are 192.168.1.0.263. For this S2, 64 to 127, 128 to 191, and for S1, S4, this is 192 to 255. So the first address is used to represent the network itself. And the last address is used for the broadcast purpose. It's the broadcast address for the subnet S1. For the subnet S1. And for subnet S2, 64.192.168.1.64 is the network address, and for the subnet S2, 192.168.1.127 is the broadcast address for the subnet S2. For the subnet S3, 128 is the network address, 191 is the broadcast address, and for subnet S4, 192 is the network address, and 255 is the broadcast address for the subnet S4. To represent, to connect the host, we use the range from 192.168.1.1 to 192.168.1.62. These are the usable address to connect the host. To connect the host, for the subnet S2, 192.168.1.64 is used for the network address. From 65 to 126, these are the usable host address for S2. And 127 is used for the broadcast address. For subnet S3, 128 is the network address for subnet S3, and from 129 to 190 are the usable host address, and 191 is the broadcast address for subnet S3. For subnet S4, 192 is the network address, 193 to 254 is the usable host address, and 255 is the broadcast address. Network address means this address will represent to this subnet, and broadcast address to send the packet to all computer. That is the broadcast address. One to all. Now let us try to solve one more example. A class B network on internet has a subnet mask of 255.255.240.0. What is the maximum number of hosts per subnet? We have to calculate the what is the maximum number of hosts per subnet. Now the given mask address is 255.255.240.0. When we convert this into binary, so four plus 1, 2, 4, 8, 16, 32, 64, 1, total is 240. Now, for to create the subnet, this is the class B network. Class B network means first two octet is used for network ID. The remaining two octets are used for the host ID. For creating subnet, we use the most significant bit from the host ID. So it is used total 4 bits to create the subnet. 4 bits to create the subnet. Now 2 raised to the power 4. 16 subnets are there in this network. In one subnet, there is 2 raised to the power remaining 12. 16 minus 4. This is 2 raised to the power 12 host in one subnet. 2 raised to the power 12 means 4096 hosts are connected. Let us take one more example. Perform the subnetting of the following IP address. This 160.111. So this shows this is the class B address. So in class B, 16 bits are used for network ID and remaining 16 bits are used for the stack. So originally subnet mask is given class B 255.255.0.0. This is the subnet mask. Now number of subnet we have to create is 6. So we have to create 6 sub. For this, we use the 2 raised to the power. 2 raised to the power 2 is 4 subnet, or 2 raised to the power 3 means 8 7. So we have to create the 6 subnet. So we use 3 most significant bit from host. Now 255 111. So, so so we use this is the class B. 8 bit shows the network. Sorry, 16 bits are used for network ID, and remaining 2 octets are used for the host ID. For this, we use 3 bits. 1, 2, 3. This is used for 3 to create the sum. The remaining 13 bits are used for the first. Now, 6 sub S1 we use 0, 0, 0. That is 255, 255 dot 0 dot 0. For S2 0, 0, 1 means 255 dot 255 dot 52 means 0, 0, 1, 5 zeros and 4 zeros. The decimal number is 32, 1, 2, 4, 8, 16, 32. This is 32 dot 0. For subnet 3, this is 0, 1, 0. That is 255 dot 255 dot 64 dot 0. For subnet 4, it is 0, 1, 1. This is 255 dot 255 dot 96 dot 0. For, for subnet 5 is 100. That is 255 dot 255 dot 128 dot 0. For subnet 6, it is 101. 255 dot 255 dot 160 dot 0. So these are the 6 subnets that have been created. Now the next example, a block of addresses is granted to a small organization. We know that one of the addresses 205.16.37.39/28. This is the CIDR notation. What it means in the subnet mask, total 28 number of ones. Total 28 number of ones are used. Now we have to find what is the first address in the block, what is the last address, and also find the number of addresses in the network. There is two methods to solve this question. To calculate the first address. This is by setting rightmost bits of 32 minus n. N is this 28. N bits, 2 zeros. 2 zeros. For example, 32 minus 28, that is remaining is 4 bits. The rightmost 4 bit, we have to set the zeros. The binary, when we convert this IP address 205.16.37.39. IP address is 110011101. This is 205.16.001.0000 dot 37.001.000101. This is 39.001.00111. This is 1, 2, 4, 8, 16, 32, 64, 128. This is 32 plus 4 to 6, 17. This is 30. Now we have to set the four rightmost bits to the zeros. Now the address is 11001101 dot 000010000 dot 001001001 001000. Rightmost four bits set to zeros. Now convert it into the decimal number. This is 205.16.37. Sorry, this is 37 dot. Now 1, 2, 4, 8, 16, 32. This is 32. This is the first address in the flow. The second method, will be the first address. It can be calculated by adding the by ending the given number with the mask address. For example, for example, the given address is 205.16.37.39. The binary is 1100101.00037. This is the IP address with the mask address. Mask address is, that is slash 28. The 28 ones, 1, 2, 3, 4, 5, 6, 7, 8, 4, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 20. Zeros. We have to do ending bit by bit. So this is one, sorry, 100, 100, 100 for ending 00, 0, 100, 111. So this is 0, this is 0, this is 1, this is 0, this is 0, this is 1, this is 0, this is 1, this is 0, this is 0, this is 1, 0, 0, dot, 0, 0, 0, 0, this is 1, 0, 0, 0, this is 1, 0, 1, 1, 0, 0, 1. If you see, convert it into decimal number 205 dot 16 dot, this is 37 dot, this is 32. So this is the first address. Now, how to calculate the last address? So this is by setting the rightmost bits, rightmost 32 minus n bits, two ones, two ones. For example, this is 11001101 dot 00010000 dot 00100101 dot 0010. This is 1111. 32 minus 28. This is forward, last forward set to 1. Now convert it into decimal. This is 205.16 dot 57 dot 124.816 32. 32 plus 8 for 12, 14, 15. This is dot 47. Dot. This is the last address. Now the second method, we calculate the last address. That is by ORing the given address with the complement of mask address. Example, that IP address is 205.16.37. The binary is 11001101.16 0001 0000 dot 001 00 101 dot 13 00100111. Now the mask complement, that is 00000000 dot 255.00.0 dot 255.255. This is the class C address. So this is 0, 0, 0, 0, 0, 0, 0, 0, wait, 8, 8, 8, 24, 25, 26, 27, 20. Remaining are 1, 1, 2, 40. 40 means 0, 0, 0, 0, 1, 1, 1, 1, 1. So this is 1, 1, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 1, 1, 1. Now converted into this is 205.16.32.124.8.16.32 plus 50. So this is the last address. Now the third question is find the number of addresses in the net. Total number of addresses in the network. One, 7. This is the mask complement plus 1. So mask complement, when we convert it into decimal number, this is 15 plus 1. The total number of addresses are 16. Second method, we calculate the total number of addresses, that is 2 raised to the power 32 minus n. N is equal to 28. So 2 raised to the power 32 minus 28, just 2 raised to the power 4. This is equals to 16 number of addresses. I hope everyone have cleared this. If we have to draw the network diagram for this organization, so this is the first router here. This is the rest of internet. The first address is our network address. That is 205.16.37.32. This is the first address that we have calculated. This is used as the network address. Now the host address, we do, this is 205.16.37.33. This is 34. So the last address is 205.16.37.47.28. This will be treated as the broadcast address. The last usable address is 205.16.37.46. So this is the network diagram. the messages with the address from 205.16.37.32 to 205.16.37 are directed to this network. Okay. Now our next topic is VLSM, variable length subnet masking. Variable length subnet masks where the subnet design uses more than one mask in the same network, which means more than one mask is used for different subnet of a single class A, B, C, or a network. Now the question is why to use variable length subnet masking and what will be the requirement. In the subnetting, we are dividing a single network into equal parts, into the equal subnet like S1, S2, S3, S4. The size of four subnet are equal. The number of hosts in the subnet S1, S2, S3, S4 are equal. If our requirement is we have to connect 100 or more than 100 computers in the subnet S1 and 50 hosts in subnet S2 and 50 hosts in the subnet S3. So we require only three subnet for the host size or number of computers that are connected together are 100 in subnet 1 and 50 in subnet 2 and 50 in subnet 3. For this purpose, we use variable length subnet masking. For example, this is a class C address for this network 192.168.1.0. We have to divide, we have to use the variable length subnet masking. So first, we will equally divide the subnet S1 and subnet S2. For this, we use for the two subnet, we require 1 bit. So there is 192.168.1. This is class C address. This is 3 octet are used for network ID, and the last octet is used for host ID. So for this 1, 2, 3, 4, 5, 6, 7, 8. For this 1 bit 0 for S1, for S2, 192.168.1.1. This is for S2. First address for the subnet S1 0, 0, 0, 0, 0, 0, 0. The last address is 0, 1, 2, 3, 4, 5, 6, 7. The first address is 192.168.1.0. The last address is 192.168.1.127. So for this subnet, this is the range. Now for S2, suppose we have to divide this S2 into three parts, S2 and S3. So this is used to connect more than 100 computers. This is used to connect 50 computers. So this is also used to connect the 50 computer. So the proper utilization of to connect the number of hosts, we use variable length subnet masking. For this, we will divide the subnet into two parts. So for this subnet, we require 2 bits to create the subnet. For this, we require 2 bits. So one more bit is used to create the subnet. For this S3, this is 192.168.1.1. The second 1, 2, 3, 4, 5, 6. The 6 bits are used to connect the host. The 6 bits are used to connect the host. So this is 1, 0 and 1, 1. The minimum is 0, 0, 0, 0, 0, 0. And maximum is 1, 0. All are ones. 1, 2, 3, 4, 5, and 6. So this is 128, 2. This is 191. And this is all our zeros. This is 192 and 1, 1. Remaining 6 all are ones. 192 to 1, sorry, 255. So the range for this 192.168.1.128 to maximum last addresses 192.168.1.191. For this subnet, S3 192.168.1.192 to 192.168.1.255. For this subnet S1, for the subnet S1, 192.168.1.0 is used as the network address to represent the subnet S1, and 192.168.1.127 is used as the broadcast address. So the usable addresses, usable host addresses from .1 to 126. For subnet S2, 192.168.1.128 is the network address. 192.168.1.191 is the broadcast address for subnet S2. Usable host addresses for S2 is 192.168.120.192.168.1.19. For subnet S3 192.168.1.192 is the network address for subnet 3. 192.168.1.255. Last address is the broadcast address for subnet S3. The usable host addresses are 192.168.1.254. These are the usable host address. Now the one more thing, what will be the mask address for the subnet S1, S2, and S3. Now for this subnet S1, the mask address we use the 1 bit. We use 1 bit to create the subnet. So the mask address for this is 255.255.10008. When we convert this, this is 128. 128. Or we can represent this via cider notation is 8 bit, 8 bit, 8 bit, 24 plus 1 slash 25. So we represent for this addresses slash for S1 slash 25. For this S2, 255.255.255. This is 1 we use 2 bits. So this is slash 192 slash 26. For this also 255.255.255.2 bits. 11000000. This is slash 26. So the advantage of variable length subnet masking that will allow the network admin to allocate IP addresses more efficiently and effectively. So this is the advantage of variable length subnet masking. We use the proper utilization of addresses. Now the next topic is what is supernetting? Supernetting is the process of aggregating the two or more network for which it generates a single IP. For example, we have divided a ABES network into 4 parts: examination, registrar, CCPD, fourth one is computer labs. So when we, for subnetting, we use the most significant bit of the host ID, but supernetting is the reverse process of this when we combine all these subnets to a single network to the ABES. So this is called supernetting. Or in this supernetting, we use the least significant bit of network ID of network ID. Suppose if we have class B address, so this is 8.8 total 16. The 16 bit are used for network ID. This 16 bits are used for host ID. So for this, for these significant bit of network ID are used for to create the supernet. So these are the references for this disclaimer. Thank you.